Well, hey guys, welcome back to the channel and welcome back to build video number 2 in the Hispano Aviation Ultimatum series. Last episode, we basically did a bunch of planning, getting the electronics ready to go. In this episode, we're going to start to get into the actual installation build of the aircraft. So stay tuned and we will dive in to this amazing orange and blue plane. All right, so last episode, we basically did a bunch of planning and got the electronics ready to install in the aircraft. So did all that. Now we're ready to actually jump into the installation process. We do have some special things planned for this aircraft. As we talked about in the first episode, gear doors being number 1, and we are going to also be installing an afterburner light in the tail section. So we're going to plan for that. We need to get the afterburner light ordered, but we'll plan for that and that won't be an issue. So what we're going to do in this episode to kick things off is we're going to pull the canopy out, pull the plates out, and we're going to start working on the tail section of the aircraft and work our way forward. So we're getting the vertical stab or rudder done. We'll get the horizontal stab, elevators done, and then we will start to see where we go from there, pipe installation, turbine, things like that. So it's going to morph into where it's going to go, but let's pull all of our parts out and get started with the tail section. Okay, so first thing we're going to do here is start taking things out. So we're going to take the front tray out, just basically to allow access for everything. We need to take the tanks out, and we also need to take the exhaust pipe out as well too, just so we can run all of our wires and get everything cleared out. So the tank is probably going to stay out until we are ready to reinstall it, but that's what we need to clear out as a first step. All right, so we've got the tank out. The tank is a very, very tight fit on this plane, but it does go in and out. Part of the key is getting it in and out of the fuselage with these little notches here. So you undo the front, tank rotates up, comes out by those notches. Front tray is also out. Pipe is still inside. The reason the pipe's inside is because you have to take the bell mouth off the pipe if you want to get it out. That's no problem because the pipe's really not interfering. There is holes in the formwork that we can run our wire through. So doing a lot of thinking here. Obviously we've got the rudder, our vertical stab cover off. These are really, really nice because they are extremely thick fiberglass material. So it looks like solid fiberglass G10 material, really stiff, really strong. So no issues at all putting your servo onto here. Now there is 3 sets of L brackets with this aircraft. 2 of them are going to go on the ailerons. 1 set is going to go on the rudder here. Everything else has mounting positions. So that's fine, easy, no problem with that. So while we're going through all this stuff, I'm just kind of giving some thought to our gear doors. Now a couple important things here is initially, if you don't put a lot of thought into it, you may run your gear doors flush or parallel with the root of your wing. Now the problem with that, when you look at the fuselage, the root of the wing is very much not parallel to the flight direction or center of the fuselage. So that has to be accounted for when you do those doors. Now some simple geometry here. Our pins are in line or perpendicular to the flight line or center line of the fuselage, so that's one key indicator. The other thing is your gear line here as well. So if you drew a straight line from the gear blocks, that's going to be kind of at this angle here, which is very close roughly to being parallel with the flight line. So our gear doors really are going to be at this kind of angle, which when the plane's all together is actually going to be straight with the middle line of the aircraft. So just doing some brainstorming around the whole gear door setup, but I just wanted to share those thoughts with you guys. So we've done all of our tests on our servos. Those have all been cycled and everything, finished those up, so they are all ready to go. There's our whole servo selection right there, including our HV69s for the gear doors. So we'll take one of these guys, doesn't matter which one, and that is now going to become our rudder servo. All right, guys, so we've got our rudder servo all set up here. So pretty straightforward. We're going with our carbon horns here. And basically all of the surfaces are going to use the MKS carbon horns with the second hole, and then the flaps, the 10 millimeter requirement is that first hole there. So these are basically designed for this aircraft. It's awesome. And so we've got that all set up, centered, all that stuff. So pretty straightforward as far as installation goes. The worst part of this is just going to be drilling through the cover and putting bolts and stuff through there. So, but not a big deal. And all we want to do is essentially get this centered side to side, this way side to side, and get that as centered as possible. Mark our holes, drill them through, fasten that in place. And that's step one of the rudder servo. Now the rudder and all of the surfaces, the way it's set up, on your servo horn side, you'll be using the linkage, like the clevis style linkage. And then on the horns that are mounted to the surface, we're using one of the aluminum ball joints. And we've got all the appropriate aluminum rods here to work for all of those scenarios. These were all supplied with the kit. You needed to take the pipe out in order to get good access to the tail section to make sure our wires are all run properly. So I figured I would show you here what the pipe looks like. So it's already marked from Hispano Aviation, so that's all done. Screws are fairly easy to take out. Quality of the pipe though is, if you ever have flown or owned an Ultra Flash, this is really similar to an Ultra Flash pipe. Very, very strong, very tough feeling inner wall, and good quality pipe. So very impressed with that, that's great. Now with the pipe out, we've got good access to everything in the back, and we'll be able to run our wires much easier. All right, so we got 3 of our servo extensions done up here, obviously using power box wire. That's what we use here at the lighter side of RC. Sounded very passionate. So we've got both of our elevators and our rudder. They're all the same length. So we've got a 5-foot extension here for each one. So that brings us from our surface and goes all the way forward, going through the various locations to the front of the tray area here. So the tray in the aircraft is this entire area. We have enough wire to go all the way to the front. So we're completely wide open as far as our layout goes. Now the rudder extension, I've done a little section of electrical tape here, so we'll glue this into the rudder hole, and that'll allow us to use shrink tubing on the actual connector, which is our norm. And then we are using the standard power box connector, and what we'll do is we'll just make a little tiny opening here, and we'll just have those glued in place. So what that allows us to do is that when the elevators come off, you just unplug the servo from there, and that will work out wonderful as well. All right, so just continuing on with the tail section of this aircraft. So we've done a couple things here. One of the elevators is complete, got everything figured out, fairly straightforward. One of the things I needed to do was put a spacer on the surface that the servo mounts to, just to get everything lined up properly. Now, if you're using a different horn, that could be different, but with the MKS carbon horns, this is the alignment that we needed, so we added a 1/8 inch spacer before screwing that servo down, and everything looks good. So I haven't done any adjustments here yet, so we need to plug this servo in, adjust our linkage length for center, and then we'll just put a drop of CA on each of those threads. Nice thing about the included linkages is one is backwards threads or left-hand threads, one's right-hand threads, so you can adjust the length of everything by the turnbuckle here. So the little line designates the left-hand thread. So cool setup like that. Now the path for everything here, we got our plugins set up on the side there for the elevator, ran that as tight to the front tube as possible, and our wires come in and they go straight up to where the rudder servo wire comes in. Now the point of going straight up like that is to get them out of the way of the exhaust pipe as quickly as possible. Linkage on the rudder here, we have not put it on yet because we need to plug in the rudder servo. So we'll just wait to do the linkage here until we get our wire ends done up front. So right now what I'm going to be doing here is working on the left elevator, and we'll just match this exact same stuff up here. Once I get those pieces of wood put in there, I'll take a shot for you so you guys can see exactly what I'm talking about. All right, so I'm just plugged in the right elevator here into our setup so we can get this centered. Figured I'd show you guys. So these linkages and everything are very, very accurate and very tight. So right now, like these threads, and I'm comparing this to like some of the other stuff that we commonly use, but these threads are really tight. There's zero play in this setup, and we're just going to put a drop of CA on there just to lock it. Now you could use a lock nut. That kind of takes away from the nice sleek look here. So we've got the servo centered from our initial setup, and we can see here, if we just turn the turnbuckle, we can get that perfectly centered. We'll just check both ends, give it a movement here. Awesome. And then once we're happy with our position, which that looks like it's perfectly centered, then we'll just, I'll put a piece of paper towel underneath here, put a drop of CA on each end, and that will lock it in place, and we're all good to go. All right, one nice little thing to do here is you can adjust your, and this is kind of, I guess, a jetty specific thing, but you can adjust your max positive limits for the servos at this point. So elevator 2, we know that number 1 is always our left, number 2 is always our right, and so this is our right elevator, and I've gone in and adjusted our limits here. So we're at 77% one direction, 55% the other. And what that does, it prevents the arm from damaging the surface, right? So now the max that this servo can travel is those preset limits. Even though our max positive and everything is at 100%, doesn't make a difference. So now no matter what our mixes are and everything, the servo will only travel that far, and then we can use dual rates and flight modes and all that to adjust the different travels. But this is a bit of a safety thing, I guess, if you wanted to call it that, just to make sure you don't put big dents in your surfaces. And I just want to take a moment and appreciate the quality put into these Hispano Aviation products. I can't talk about it enough. These planes are stunning. If you ever get the opportunity to own a Hispano Aviation plane, whether it's a Bull, an Ultimatum, or whatever else they manufacture, man, you will not be disappointed. So I just want to show you something inside the tail here. Just the layup and quality is just phenomenal. So we've got some Kevlar in the back section here. It's just beautiful. Man, little things, and you'll never see that, but when you're putting your plane together, those little things, I tell you, they are stunning. Okay, so there is the opening for the servo, for the elevator servo. So all I do is on the surface that's visible to us, I'm going to glue those little wood blocks. So I'll glue those in place. Don't need to pre-drill them. We can drill that once the servo is installed, but I'll get those blocks installed and show you what they look like. All right, and there's a shot there of inside the elevator with our little pieces of wood glued in. Just use CA to glue those. So what I do now is install the servo, and then once the servo is installed, there's just enough room to drill the holes, and we'll get that screwed in place. Now the servo is definitely a tight fit, but you can see there we are right bang on in the center of our channel. That is exactly what we're looking for. Okay, so our tail section is all complete. We've got our elevators on, our rudder is all done other than the linkage, and that is good. Now we are adding a afterburner light to this setup, and what I've ordered is a Unilight 92 millimeter afterburner light, and I think it's just going to fit in this area. We may have to sand down the top and the bottom a little bit. You can see the back end here is a little bit oblong or egg-shaped, right? So a little bit squished top and bottom, wider side to side, but I think it should work perfectly. So what I'll do in preparation for that is just run a string where we want to run the wire. So the Unilite wire is a high temperature silicone wire, so that can touch the pipe, it doesn't matter. So what we'll do is we'll pick a side here, one of these bigger slots, and we'll just run our string forward. So we have the ability to install the Unilite afterburner light when it arrives. And then I'm going to run some snake skin on those wires, and we'll get that done up here next. Now the snake skin, we kind of want to run it back to the plugs as close as possible because we're going through a former here that has carbon and wood, and then we're going to be going through the different formers in the aircraft. So chances are probably going to run that snake skin all the way forward to where it comes through this front former and goes underneath the board. That way all those lines will be protected. So we'll get that done here next. Okay, so we've got the snake skin covering the back wires, and that is all run to the front former here, comes just in front of the former. Now, to fasten the snake skin onto the locations in the fuselage, I just put some electrical tape around there, a little bit of thick CA, and works perfectly. So now we're nice and stuck to the sidewall, and the way I glued it, there's just a little bit of relief back here for those wires, so they're not pulled tight, they're just loose. So I haven't run the wire yet for the afterburner or the string. We'll do that though. What I was working on here was the intake screen. So we want to put some screens over top of the intake. Really love using this. It's just window screen material, but you can buy it in metal. So this is metal, holds its shape, nice and durable. So all I did was take a piece of thick paper here, hold it over the intake, draw it out from the inside, and that's the shape that we get. So what I'll do is I'll cut this out, leaving about 5 to 7 millimeters around the perimeter, and then we'll have our screens. Those screens we can glue from the inside. To glue those in place, we just hold them in place, tack them with CA, and then I'll use some high sol to make sure they're nice and strong and they're not going to go anywhere. All right, so we've got our screens installed here. Right now they're just CA'd in place just to get them, I guess, tack welded in place. So we've got a bunch of spots of CA all around the perimeter. Worked out awesome. It's actually really nice, easy access on this aircraft. So what I do now is mixed up some epoxy. This is BVM stuff that I'm trying, but it's just like high sol as far as color and stuff goes. But now what we'll do is we'll install this around the perimeter of it, and then once that's cured, we'll paint it black and it will basically disappear, or gray, whatever we have. But the key here when you're doing this is keep it away from the opening. So you want to make sure your screen's cut big enough that you've got some room here, because if you go into the opening, cleaning it off is a real pain in the butt. So anyways, we'll get that done. And then what we're going to do is start to work on the pipe and turbine mounting. So unfortunately with this setup here, I would generally rivet the bell mouth onto the pipe, but if we do that, it's not very removable when it comes to the bell mouth and stuff. So we're going to avoid doing that, and we're going to use the bolts and nuts and everything that came with it. We're probably going to put a split washer on here though, which is going to help to keep those bolts tight. You can't really use Loctite on the nuts and bolts because the heat generated back here is probably going to melt the Loctite or make it not effective. So that's what we're going to do now, is get that pipe back installed. But we do need to run that string forward for the afterburner light. So we'll do that next. The one downside to this BVM stuff is I don't actually like how thin it is. It's a little bit thinner than 9462 from high sol or Loctite. So that we're going to let that kind of kick off just a little bit, or I may add some material to that actually. Actually, that's what I'll do. I'll add some Cabasil to this, and that'll help thicken it up and stay in place. Then we'll be able to do this, run the string, then get the pipe installed. All right, so we got our string run to the back there. Next thing we're going to do is we're going to cut the engine rails down here. Now it's nice that Hispano Aviation put nice wide rails in here, so if you wanted to put like a tiny 100 Newton or even maybe an 80 on this guy, it's going to fly awesome. It's going to fly it quite well, and the spacing here allows that. But if you're going with the bigger turbine, you're going to have to cut this down, which is no problem. For our Swiwin 170, we're basically going to cut it so it's so this rail is straight all the way to the back, and that's going to work out very well for our engines. So that's the next thing we're going to do, because we can't get our pipe lined up until our engine's installed. So we need to get these rails cut, then we'll put the pipe back in. All right, so engine rails are sanded down. Now there's really no good way that I could think of to get in here now. Actually, now that I talk about it, I think I have a tool that would work perfect. But anyways, I used my super Dremel that or what I call my super Dremel, and we sanded those rails down, which was quite a task because we needed to get rid of about ½ an inch of material. But the Dremel and the vacuum worked out beautifully, so that's how we got those sanded down. All right, so this is one of those common things that I get asked very often, and that is, how do you, number one, align the pipe to the turbine? How do you get the turbine spaced properly and all that kind of stuff? So here's a bit of an overview for you. We've got the pipe installed, we've got the bell mouth installed, and the bell mouth is just sitting there. So we haven't put any fasteners through the holes yet, and that's because we are going to be bolting the bell mouth to probably the engine rails here. So we kind of need to get this positioned first, figure out where we need to drill holes in the bell mouth, pull the bell mouth out, drill those holes, and then get everything reinstalled. So we've got the turbine sitting in there. Again, we don't know where its center is yet, so we're just bolting the resting the turbine in there like that. Now I haven't looked at the back end here yet, so this is the first time we've looked in. And we'll just see how things look. So that pipe right now is, the bell mouth is resting on the bottom of the fuselage, and we can see, based on the position of the turbine, that that bell mouth needs to be raised up. So I knew that, but we need to, just wanted to confirm it obviously and show you guys the process. So we don't need to come up very far. If you look at the turbine there, we're probably coming up about 1 centimeter, so 10 millimeters, which is about 3/8 of an inch, I think. And so that's kind of the up and down that we need to do. So we'll just start adding spacers underneath the bell mouth until we are perfectly satisfied with our up and down position. So the up and down position in this case, we are adjusting with the bell mouth and the final screw in position. The side to side is going to be adjusted with the turbine, because we've got some wiggle room here, side to side, so we'll be adjusting that. And of course the spacing in and out of that bell mouth with the turbine as well. Now we do have a little bit of a restriction here as well too, so we got to keep in mind where our tank is sitting as well. So we want to make sure that our turbine is not going to interfere with the tank. So let's put the tank in now temporarily and take a look at that. Okay, and I'll show you guys how the tank goes in here. We may have to slide that turbine back a little bit to make some room, which is fine. So tank, you can see we've got our little cutouts right here, or little reliefs. So that's where the base of the tank goes in, or the back base. And then we just get the forks installed on the wing tube and drops in place, no problem. So we'll slide this all the way forward. Our mounting holes are here, tanks all the way forward, which is good. So we're about there roughly. Now what I'll do just for spacing is I'll get my turbine installed in the bell mouth. So this is also a very common question, turbine spacing to pipe. Okay, so let's cover a little bit of this stuff. This is what we'll call scenario number one. You have your pipe with either no bell mouth, or there's just a little flange like this, a little tiny, we'll call it a mini bell mouth. Okay, you want to, in this case, and always follow your manufacturer's recommendations. This is not 100%, but it pretty much works for everything. So your turbine exhaust cone comes like this. Now your actual measurement is from the tip of the exhaust cone to the pipe, not the bell mouth or the mini bell mouth. So the actual pipe itself, you want this distance right here to be 25 to 30 millimeters. Okay, that's the older, more common scenario. Okay, scenario number 2, you've got a pipe and you've got a little bit of a bigger bell mouth like this. Okay, not very long. You know, maybe you've got a bell mouth kind of like this. You follow the same directions. So from this pipe right here, not the bell mouth end, which is right there, you go 25 to 30 millimeters to your exhaust cone. Don't measure that from the end of the bell mouth. You're always measuring from the pipe. Now in a scenario like we have in this plane and many other planes, you've got a large, or your pipe, and you've got a large bell mouth, like this exact same scenario. So what you want to do in this case, just finish off our bell mouth. So what you want to do in this case is you want to split the difference. A good resource for this would be the Gromania pipe website. They've got a nice layout here. So you kind of want to go 50-50. So if this bell mouth, and this is probably going to be upside down, if this large bell mouth is 3 inches, you're going to want to go 1.5 from this point to the mid, 1.5 from this point to the mid, and that's where your turbine exhaust cone wants to go. Okay, so that's kind of the 3 different layouts that you'll find in most turbines. Now we should probably call this a tip time because we haven't had a tip time in a while, and this tip time has been brought to you by trusty bent screwdriver. Okay, so we've got our turbine roughly sitting, we don't need to do any measurements right now. We've got the turbine roughly sitting at the 50%-ish mark inside the bell mouth. So we're just eyeballing this right now. We may go a little bit further back once we measure it, but that's kind of what we're looking for. And if I go any further forward, the turbine's actually going to contact this former right there. So we need to keep that in mind as well. And we've got a good amount of space there from the front of the turbine to the back of the fuel tank. It's about 1.5 to 2 inches. So that gives us a good idea on our layout. So what we need to do now is we need to raise this bell mouth up like that. We can put some spacers underneath it, and we'll keep raising it up and getting it positioned until we are 100% happy with the up and down position relative to the turbine. All right, so a couple of my tricks here for fitting the engine. So I've got a long piece of wood, a dowel. In this case, it's a right angle. And what I do is I put this in from the back of the aircraft, have the front sitting against the bell mouth to pipe joint, and mark that position where it is in relation to a fixed point. So in this case, it was the outer wall of the pipe itself. And then what I do is take this same rod, slide it in till this end is now contacting the tail cone, and mark that same point, which is there. And this is our distance that we have between the tail cone and the bell mouth to pipe joint. So in this case, it's 1 3/4 inches. This bell mouth is a 3-inch bell mouth, so we needed to take our turbine and from the position we had it in when we measured and put it in 1/4 inch, which is what we've done. So when I measured this all out, what I did was I took that turbine, jammed it all the way forward against the former right here. That's where this measurement came from. We needed to move it back 1/4 inch. So now what I do is I take that turbine, move it back 1/4 inch. Now we've got our position relative to the bell mouth. So underneath the bell mouth, I started off with a 1/4 inch spacer. That was way too much. Then went to 2 1/8 inch spacers. That was way too much. And now we've got a single 1 inch spacer underneath the bell mouth, and we are perfect. So getting the pipes centered or the turbine centered in the pipe really doesn't need to be overly complicated, guys. My process is this. So as I've shown you already, step number one is getting the bell mouth or entrance of the pipe set up and down in relation to the turbine. Then we can get the turbine kind of positioned in and out of the pipe so we're in the right location or as close as possible. And then what I'm doing from that part, once I've got the bell mouth or pipe up and down set, the turbine in and out set, is we start to adjust the turbine angles. So there's a couple different things you're looking at here, and it really all comes down to symmetry. So when you look in the back of that exhaust pipe, look for symmetry in everything. So you want to look and see the same spacing all around the exhaust cone of the turbine itself. When you look at that exhaust cone, you don't want to see a whole bunch of one side of the exhaust cone. That means the turbine is shifted side to side. So I'm kind of playing around with things a little bit. Number one, I'm trying to get that exhaust cone so it's the same picture all the way around, and I'm not seeing a bunch of one side of the exhaust cone. Once I get that set, I know the turbine's pointing straight backwards. From there, we can take and adjust that outer cone. So if we're seeing a little bit more on like this side of the turbine, a little bit more space, this side's tight, then you're just taking the whole turbine and moving it side to side, not shifting the angle. So again, all you really want to look at is symmetry in the back end of the turbine. So this is really tough to pick up on camera, and I'll do my best here, but that is what we're looking at. So when I look at that exhaust cone, it's the same profile all around the exhaust cone. When I look at the outer part of the exhaust cone where it bolts to the turbine itself, where the bolts are, we've got the same profile exposed all the way around the turbine. So that turbine is very well centered right now, and I trust my eyes. They work amazingly well. Your eyes do too, so don't be scared to trust your eyes, and just take a good look and take some time and think about what you're looking at. Okay, so next thing we want to do, we've got our pipe set up, we've got our turbine set up. We don't want to touch any of that stuff. What we want to do is we want to figure out how we're bolting down our turbine. So in this case, we've got options. We have the inner bolts, the outer bolts. We'll probably do a combination. So we'll do the front and back inner bolt, we'll do the center outer bolt, and we'll put 3 in each side. I'm a huge fan of wood screws when it comes to mounting turbines. You can use blind nuts if you'd like. Of course, you can use whatever you want, but wood screws work very well. And once I get them installed and I'm happy with everything, I'll treat the threads with a little bit of thin CA to stiffen them up. But once the turbine's in for the last time, put a little drop of thin CA in the hole or on the screw, tighten the screw down, the wood screw, and it doesn't come out unless you want it to come out, and works absolutely awesome. So I'm going to mark those turbine mounting holes with a paint marker. Probably just going to mark all 6 so we've got them done. Then what we'll do is we'll pull the turbine out, and we have to mark the bell mouth where we want to drill those holes in relation to the engine mounts. So I'll do the turbine first, then we'll take the bell mouth out after marking it and get that drilled. All right, so we've got everything marked out here. We've got our 3 white dots for each side of the turbine. And what I've done here on the pipe is on the actual former itself, right on the front edge of the bell mouth, I did a little pencil mark, and then we did a Sharpie mark where we need to drill out the bell mouth. And that's going to be our screw hole that goes into our plywood and carbon engine rails. All right, so these are the split washers that we're using on the pipe. And these are designed so that when you tighten them up, the nut doesn't come loose. So that's what we're going to put on the pipe to hold the nuts and bolts together. All right, and I already know that some of you guys were definitely triggered when I put the rudder together and used regular socket head Allen key screws. Don't worry, relax. Found some button heads, 4 of them, so we can switch those out and use button heads on the servo cover. All right, we've got the turbine and pipe installed. Everything looks outstanding. So we ended up using 3 screws on each side, just like we talked about, and it is beautiful. So I don't think we're gonna have to take that out again, but we'll see. But hopefully that's the last time, and the engine is in to stay. And there's the customary shot up the tailpipe for you. You can see the line there for our afterburner, and we're all good. So that turned out awesome. All right, guys, and that is going to be everything for video number 2 in the Ultimatum build series. Obviously, in this video, we got the tail end, the back end done, our elevators are done, our vertical stabs done, our pipes reinstalled, and our turbine is installed. So making quick work of this plane. It's actually going to be a quick build, but all of the extra items that we're planning on doing are going to add some more time. So if you're buying one of these things, it definitely will go together quite quickly, but our lighting system is going to add some time. That's probably the biggest one, and the gear doors are going to be a huge time thing as well too, just figuring things out. So that's it, guys. Thanks so much for watching the build series. If you're interested in one of these things, check out AeroPanda. Links down below to AeroPanda's website, and you can also go to the Hispano Aviation website because there are different dealers all over the world. So check that out, guys. Thanks for watching. Don't forget to give the video a thumbs up. Hit that subscribe button down below if you're not a subscriber, and we'll see ya in the next video.